binomial expansion with the second method for doing binomial expansion. That's using the binomial theorem. First of all, the binomial theorem states that in the expansion of a plus b raised to power n, the first term of the expansion should be n combination 0 times a raised to power n minus 0 times b raised to power 0. Take note of where I'm getting my n. This is my a, this is my b, this is my n. That's the first term. The second term should be n combination 1 times a raised to power n minus 1 times b raised to power 1. Notice that in this formula 2, the coefficients of a will start from n and that of b will start from 0. The coefficients of a will reduce from n to n minus 1 and increase from 0 to what? 1 and so on. So our third term should be n combination 2 a raised to power n minus 2 b raised to power 2. My fourth term should be n combination 3 a raised to power n minus 3 b raised to power 3, and so on till you get to the term before the last, which is n combination n minus 1 a raised to power 1 b raised to power n minus 1. Let me write that very neatly. A raised to power 1 b raised to power n minus 1. Sorry, I'm rewriting. Just want it to be clear. And the last term is n combination n a raised to power n minus n, which is 0, then b raised to power n. So this is the binomial theorem. Let's now quickly explain something that's very, very essential in this binomial theorem, and that's the meaning of the factorial. The meaning of the factorial. Let me just write that in green. The factorial, because we can't do combinations and permutation and what's it called if we don't know the meaning of the factorial. The factorial is such that n factorial is n times n minus 1 times n minus 2 times n minus 3 ... and so on. So that means, for example, 3 factorial is what? 3 factorial is 3 times 2 times 1. 5 factorial is what? 5 times 4 times 3. 5 times 4 times 3 times 2 times 1. 4 factorial. 4 factorial is what? 4 times 3 times 2 times 1 and so on. So also there are some simple rules in factorial which says 1 factorial is equal to 1, 0 factorial 2, 0 factorial also is equal to what? 1. Let me try and write that one. So these are some basic rules in factorial. Then n combination r is equal to n factorial over n minus r factorial times r factorial. Please take note of those symbols. Let me try. Times r factorial. So that's the meaning of n combination r. So take for example, if I have 5 combination 2, 5 combination 2 will be 5 factorial over 5 minus 2 factorial times 2 factorial. So 5 combination 2 will be 5 times 4, 5 times 4 times 3 times 2 times 1. But instead of writing 2 times 1, I can represent the rest with factorial. In fact, I can, instead of writing 3 times 2 times 1, I can just stop here and represent the rest with factorial. So a factorial sign here shows that I mean 3 times 2 times 1. So this bracket will give me 3. There's a factorial outside, so that's 3 factorial times 2 factorial. The reason I had to stop at this top here is because 3 factorial can divide 3 factorial. So my answer will be 5 times 4 over 2 factorial, which is 2 times 1, 2. And that gives me 10. So you must know how to do simplification of factorials. Let's take another example. If I have 7 combination 4, that will be 7 factorial over what? 7 minus 4 factorial times 4 factorial. Now, 7 factorial is 7 times 6 times 5 times 4 factorial. I don't need to write the rest. 7 minus 4 factorial here. 7 minus 4 factorial here is 3 factorial. Sorry, then times 4 factorial. So in this case, my 4 factorial will be divided by 4 factorial. Then I have 3 factorial here. On this denominator side is 3 times 2, it will divide 6. So I have 7 times 5 left, 35. So evaluating factorials and finding n combination R at any point in time is very essential for using the binomial theorem for expansion accurately. So let's take the first example. In the first example, we did 2x plus 3y. In the first example, we did 2x plus 3y raised to power 4. We did this with the Pascal's triangle. Let's now do it with the binomial expansion theorem. In this case, we don't need to write our coefficients out, just the combination. So that will be what? Using the binomial theorem. In order to remember easily, let's write the binomial theorem out. Using the binomial theorem. The binomial theorem is what? A plus b raised to power n is n combination 0, a raised to power n minus 0, b raised to power 0, plus n combination 1, a raised to power n minus 1, b raised to power 1, plus next term n combination 2, a raised to power n minus 2, b raised to power 2, plus n combination 3, a raised to power n minus 3, b raised to power 3, plus and so on, n combination. Okay, let me make it 2 times written at last, at the end, plus up to second but last term is n combination n minus 1, a raised to power 1, b raised to power n minus 1, plus the last term. Last term is n combination n, a raised to power 0, b raised to power n. So it's a technique. As you write it, you master it with time. So therefore, doing 2x plus 3y raised to power 4 with the binomial theorem will give us, in this case now I'm not going to write n again. My n is 4, so I'll just write 4 combination 0, because I should start from n combination 0. A raised to power 4 minus 0. Instead of writing 4 minus 0, I can leave it as 4. B raised to power what? Times, although I'm not putting that. Oh, excuse me. My a, I don't have a in this question. My first term here is 2x, so I'm supposed to write n 4 combination 0 times 2x raised to power 4 minus 0. Instead of 4 minus 0, let's just leave it at 4 times 3y raised to power 0. That's the first term. Plus second term will be 4 combination 1 times 2x raised to power 4 minus 1. This should have been 4 minus 1. but I can write my 3 straight to just make our steps short. 2x raised to power 4 minus 1, 3y raised to power 1. I'm doing this, right and combination 0, which is 4 combination 0 here. Take 2x, raise it to power 4 minus 0, 4. Then take 3y times, take 3y, raise it to power 0. Then for the second term, I'll have 4 combination 1, which is now n combination 1. Take 2x, raise it to power 4 minus 1, 3. Then take 3y, raise it to power 1. Exactly. So in my third term, I'll go ahead, take 4 combination 2, take 2x, raise it to power 4 minus 2, 2. Take 3y, raise it to power 2. Exactly. So that's my third term. My fourth term will be 4 combination 3 times, I'll go here, take 2x, raise it to power 4 minus 3, 1, 4 minus 3, 1. Then times, take 3y, raise it to power 3, not 1. You understand? Plus last term, 4 combination 4 times 2x raised to power 4 minus 4 times 3y raised to power 4. So all I need to do here first is get the value of each of my n combination r. 4 combination 1, what's it? That's 4 factorial over 4 minus 1 factorial times 1 factorial. 4 factorial is 4 times 3 factorial. You know, I'm supposed to write 4 factorial as 4 times 3 times 2 times 1. But instead of writing 3 times 2 times 1, I can just leave this as 3 factorial. Because on the denominator side, this bracket will give me 3 also with factorial outside. So 3 factorial. 1 factorial is 1. That gives me 1. So, you know, if I evaluate 3, we divide 3 factorial. 3 factorial we divide 3 factorial. I have 4 over 1 left, 4. So my constant for this place is what? 4. So, no, did I do that well? Okay, I'm not supposed to do 4 combination 1. In my first term, the coefficient in my first term is 4 combination 0. 4 combination 0, 4 combination 0. Excuse me, I'm sorry about that mistake. 4 combination 0 is 4 factorial over 4 minus 0 factorial times 0 factorial. 4 factorial, leave it like that. 4 minus 0 here in this bracket will give you 4. Then with the factorial outside, you get 4 factorial. 0 factorial here is 1. So 4 factorial we divide 4 factorial. 1 over 1 gives you 1. So my first coefficient is 1. You know, exactly what I would have gotten or what I would have used in Pascal's triangle. Then 2 raised to power 4, 16. X raised to power 4, x raised to power 4. So that's 1 times 16 x raised to power 4. 3y raised to power 0 is 1. So I can forget about that. Let's go to the second term. I've done 4 combination 1. 4 combination 1 is 4. So that's 4 times here 2 raised to power 3 is 8. X raised to power 3 is x cubed. So that's 4 times x cubed. 3y raised to power 1 is 3 raised to power 1, 3. Y raised to power 1, y. So that's 3y. Let me write that one. That's my second term. Now, in my third term, my constant is 4 combination 2. In my third term, my constant is what? 4 combination 2. So first thing, I will evaluate my constant, 4 combination 2. 4 combination 2 is 4 factorial. 4 factorial over 4 minus 2 factorial times 2 factorial. I'm trying to make it big, clear, in order to avoid confusion. 4 factorial here is 4 times 3 times 2 factorial. In this bracket, 4 minus 2 is 2. With the factorial outside, that gives me 2 factorial times 2 factorial. So as you can see, 2 factorial, we divide 2 factorial. Then you have 4 times 3 over 2 times 1 left. 2 factorial here is 2 times 1. 2 we divide 4, you have 2. 2 times 3, 6. So that means 4 combination 2 is what? 6. So in my third term here, my coefficient is what? 6. So I'll go ahead and write, did I write the plus there now? Plus 6 dot, let me now evaluate the x. This is 2 raised to power 2, 4, x raised to power 2, x squared, that's 4x squared. Then 3 raised to power 2, 9, y raised to power 2, y squared. So that's 6 dot 4x squared dot 9 y squared plus, what's my next term? My next term, I've done this. So I'm going to the fourth term now. 4 combination 3. Let's evaluate that. 4 combination 3. 4 combination 3 is 4 factorial over 4 minus 3 factorial times 3 factorial. 4 factorial is 4 times 3 factorial. I don't need to split it into 3 times 2 times 1. I can just write everything as 3 factorial. So 4 factorial is the same thing as 4 times 3 factorial. Then 4 minus 3 here is 1 with the factorial outside. That gives me 1 factorial, 3 factorial. So check your, common factors. 3 factorial divides 3 factorial. 1 factorial is 1. So 4 over 1 will give you 4. That gives me 4. So the coefficient of my fourth term is what? 4. So I'm going to write 4 dot, let me now do the x. Here, this is what? 2x all raised to power 1. That's 2 raised to power 1 to x raised to power 1, x, 2x for this part, times 3 raised to power 3, 27, y raised to power 3, y cubed. Be careful here. Everything inside the bracket is raised to power 3. So 3 raised to power 3, 27. That's 3 times 3, 9. 9 times 3, 27. Then y raised to power 3 is what? Y cubed. So that gives you 2x times 27 y cubed. My next term is what? The fifth term. 4 combination 4 here. For the fifth term, my constant is 4 combination 4. So let's evaluate 4 combination 4. 4 combination 4 is 4 factorial over 4 minus 4 factorial times 4 factorial. That's 4 factorial. That's 4 factorial. 4 minus 4 here is 0. With the factorial outside, I get 0 factorial times 4 factorial. This cuts this. So I have 1 over 1. 0 factorial is 1. So 1 over 1 times 1 will give me 1. So the coefficient of my fifth term is 1. So I'll write 1 times 2x raised to power 0 is 1. From here, in my fifth term, 2x raised to power 0, that's 2 raised to power 0, 1. X raised to power 0, 1. So that gives me 1 times 3 raised to power 4 is 81. 3. Everything inside this bracket is raised to power 4. So 3 raised to power 4 is 81. Y raised to power 4 is y raised to power 4. So that's 1 times 81, y raised to power 4. So all I have to do now is simplify. What's my first term? 16x raised to power 4. I'll write that. 16x raised to power 4. My second term is I need to multiply constants here. 4 times 8, 32. 32 times 3, 96x cubed y. This is x cubed y. That's what? 96 x cubed y plus, what's my third term? I think I have that right on this page. 6 times 4, 24. 24 times 9, that should be 216 x squared y squared. Let's go to the next page. That's 2. Yours should be on a single file. I'm trying to make it big enough to see, but that's costing me, being able to write it on a single file. But in your note, you should be able to write it on a single file with your handwriting. So my third term is 216 x squared y squared. Let's go to the fourth term. This is my fourth term here. I'll multiply constants first. 4 times 2, 8. 8 times 27 will also give me 216 x y cubed. Then plus the last term, 81 y raised to power 4. This is the expansion of 2x plus 3y all raised to power 4 using the binomial theorem. Let's take a second example. What was the second example we did it? Let me scroll back. Okay, my second example was x minus 2y all raised to power 5. Let's do that quickly. Second example, example 2, x minus 2y all raised to power 5. So in this case too, I don't need to write the binomial theorem anymore. Let me just go straight. My answer will be 5 combination 0 for first term times x raised to power 5 times minus 2y raised to power 0. Can you see the way I'm picking my values? First thing, I'll write 5 combination 0 for my first term. Then take x raised to power 5. Then take minus 2y raised to power 0. You're familiar with that now. Plus my second term will be 5 combination 1 for its coefficient. 5 combination 1 times take x, raise it to power 4 now instead of 5. Raise it to power 4 now. Then take minus 2y, raise it to power 1 now. Minus 2y raised to power 1. I think I should just list it vertically like this without trying to squeeze it on a single line. So my third term, we have coefficient. My third term, we have coefficient 5 combination 2. Then x raised to power 3 minus 2y raised to power 2. My fourth term, we have coefficient 5 combination 3. Then x raised to power 2 times minus 2y raised to power this 3 here. Then my fifth term, we have coefficient 5 combination 4. I'll take x raised to power 1, take minus 2y raised to power this 4 here. Then my last term, which is my sixth term, we have 5 combination 5 as its coefficient. Then take x raised to power 5 minus 5, 0. Take minus 2y raised to power 5. So what I need now is simplification. Let's just go ahead and find each coefficient. For the first one, 5 combination 0 is 5 factorial over 5 minus 0 factorial times 0 factorial. So that's 5 factorial. That's 5 factorial times 5 minus 0 here is 5 with the factorial outside, then times 0 factorial. 0 factorial is 1. So I can change this to 1. This will divide this. I have 1 over 1. My answer is what? 1. So the coefficient of my first term is what? 1 times x raised to power 5 minus 2y raised to power 0 will disappear. Minus raised to power 0 plus, you understand? 2 raised to power 0, 1. Y raised to power 0, 1. So that will be times 1. It will disappear. Go to my second term. The coefficient in my second term is 5 combination 1. 5 combination 1 is 5 factorial over 5 minus 1 factorial times 1 factorial. So I'm going to be fast now because you're familiar with it. 5 factorial is the same thing as 5 times 4 times 3 times 2 times 1. But instead of writing all of this, I can just represent this remaining side with 4 factorial. So I can write, 5 factorial as 5 times 4 factorial. So that's why I stopped here. So then on the denominator side, 5 minus 1 here will give you 4 with the factorial outside the bracket, 4 factorial, 1 factorial. This will cut this. 1 factorial is 1. 5 over 1 is what? 5. So take note of these simplifications. I will soon, start speaking them. This will be what? 5 times x raised to power 4, then minus 2y raised to power 1. So I have to be careful here. Minus raised to power 1. Let me do this. Minus raised to power 1 is what? Minus. We said odd is negative, even is positive. This power is an odd number. So the answer will be negative. 2 raised to power 1. So minus raised to power 1 is minus. 2 raised to power 1 to y raised to power 1, y. So that gives times minus 2y plus, what's my next term? 5 combination 2. For my third term, the coefficient is 5 combination 2. That's 5 factorial over 5 minus 2 factorial times 2 factorial. That's 5 times 4 times 3 factorial over what? 3 factorial times 2 factorial. This will cut this. 2 times 1, 2. 2 in 4, 2. 5 times 2 will give you 10. So the coefficient of my third term is what? 10 times x raised to power 3 times this minus is now going to be raised to power 2, which is plus. You understand it? The third term has minus 2y. This place should actually contain minus 2y raised to power 2. So I don't want to write too many steps because of time. I'll do minus raised to power 2 plus 2 raised to power 2 for y raised to power 2. That's what? Y squared. So my term will be 4 plus 4y squared. That's my third term. Going to the fourth term, the coefficient of my fourth term is 5 combination 3. 5 combination 3, as you will notice if you do it yourself, 5 combination 3 will give you the same answer as 5 combination 2. Let me simplify so you can see it. 5 combination 3 is what? Let me simplify so you can see that 5 combination 3 is what? 5 factorial over 5 minus 3 factorial times 2 factorial. 5 combination 2 is also 5 factorial over 5 minus 2 factorial times 2 factorial. Sorry, this place is 5 minus 3 factorial times 3 factorial. So at the end of the day, the denominator will be the same. This side, for this side, I'll get 3 factorial times 2 factorial. I'm sure you're getting what I'm saying. For this side, I'll get 3 factorial times 2 factorial. For this side too, I'll get what? 2 factorial times 3 factorial. So essentially, this and this are the same. So that means 5 combination 3 is the same as 5 combination 2. Take note of that. So my coefficient for the fourth term is also 10. That's 10 times, x raised to power 5 minus 3, 2, times, this should contain minus 2y raised to power 3. Minus raised to power 3 is what? Minus 2 raised to power 3, 8, y raised to power 3. That's what? Y cubed. So this place I should have minus 8 y cubed. That's my fourth term. My fifth term should have coefficient 5 combination 4. 5 combination 4 is 5. So that's 5 times what? X raised to power 1 times what? Minus 2y raised to power 4. Let's do the simplification together. Here, minus raised to power 4. Even is positive, that's plus sign. 2 raised to power 4 is 16. Y raised to power 4 is what? Y raised to power 4. So that gives me, what does that give me? That gives me 16 y raised to power 4. Then the last term is 1. The last term we have coefficient 5 combination 5, which is 1. So this gives me 1 times x raised to power 0 times, I will now have minus 2y raised to power 5 here. Here too, excuse me, minus raised to power 5 is minus 2 raised to power 5 is what? 32. Then y raised to power 5 is y raised to power 5. So I'm supposed to do minus 32 times minus 32 y raised to power 5. Let me write that much closer. Minus 32 y raised to power 5. So all I need to do now is evaluate. What's my first term? My first term is not complex, so I get x raised to power 5. My second term, I have, there are constants here that are not having the same positive sign. So this is plus 5 times minus 2. All of this is my second term from the first sign to the last letter. So the constants in that term will be multiplied to get a single value. Plus 5 times minus 2 will give me minus 10. So that's minus 10x 4y. Let me write that. Clean this and put minus 10 x raised to power 4y. So third term. What's my third term? Let me simplify that too. This is my third term. All of this is my third term. So I'll multiply the constants in it first. Plus 10 times what? Plus 4. Plus 10 times plus 4 is what? Plus 40. So that's plus 40x cubed y. Plus 40x cubed y squared, not y. Plus 40x cubed y squared. We now go to the fourth term. So I've done first, second, and third term. Let's go to the fourth term. All of this is my fourth term. All of this is my fourth term. But I have two constants in it, plus 10 and minus 8. I'll multiply. Plus 10 times what? Minus 8 is minus 80. So my fourth term will be minus 80x squared y cubed. Let's put that down. Minus 80 x squared y cubed. Then my fifth term. What's my fifth term? This is my fifth term. Plus 5x 1, 16y4. So I multiply the constants in the term. 5 times 16 is 80. So I'll get 80x y raised to power 4. Let's put that down. Plus 80x y raised to power 4. My fifth term is minus 32 y raised to power 5. So yours should be on a single file since your note has enough space instead of breaking into pieces like this. This is my fifth term. Here, 1. My fifth term is all of this. But first thing is, I'll multiply the constants in it. The constants in it are what? Plus 1 times minus 32. Plus 1 times minus 32 is what? Minus 32. X raised to power 0 is 1. And y raised to power 5. So that gives me what? Minus 32 y raised to power 5 plus 1 times minus 32 is minus 32. X raised to power 0 is 1. So that's 1 times minus 32. Plus 1 times minus 32 will give me minus 32. So I'll write minus 32 y raised to power 5. That's the expansion of x minus 2y raised to power 5 using the binomial theorem. Let me give you just two questions to to exercise your mind, to do as an exercise, to exercise your mind. So expand using the binomial, expand using the binomial theorem, expand and simplify using what? The binomial theorem. Expand and simplify using the binomial theorem. 1. X minus 3y raised to power 4. 2. 2a minus 5b raised to power 3. Let me make it 3 questions. 3 m minus 3n raised to power 4. Excuse me. So take this as your exercise for the topic.